This really okay. So this talk I gave a few weeks ago at JavaScript Chicago. But for us, what I really want everybody to do is be as engaged and possible in asking questions, because this is the new version of Steel. I hopefully will have a lot of your guys' support in this project, and you'll want to use it, you'll want to develop it, and you want to make it better the same way that you guys have been doing for CanJS. So a lot of this is going to go over how Steel is built and what the direction of the ES6 Module Loader spec is, and those kind of things. I really believe strongly that it is the future, and I think my goal we've had a lot of debate about Steel, and I think that this is the best possible solution for us as a company, because not only does this kind of new version of Steel really support what I think is the future of JavaScript development, which is the ES6 Module Loader spec, most of the technical stuff, the really hard stuff, at least for the client loading, is done by somebody else, which we don't have to maintain. We do have to maintain our own build system, but we were the first people to really have a really good ES6 Module Loader build system, and that's valuable, and we need that anyways, and that's the special sauce anyways. So with that in mind, keep the questions coming, because I want you guys to know how to develop this and how it all works when I'm done with this. So I'm going to give this presentation a little bit differently. Oh, I realized I'm not sharing my screen. I'm going to be a little bit more technical than I was even in the even at JavaScript Chicago. So can everybody see my screen? Because I can't see you guys now.
Yeah, we can see it.
And then Brian, if my internet does go out, just text me or something, so I'm not talking to nobody.
Okay.
Thank you. Okay, so first thing we're going to learn about ES6 modules. I'm going to gloss over this stuff. You guys all know how I kind of walk people through how module loading used to work. We just loaded scripts. If you wanted to do that, so this is kind of static loading, where you kind of knew about your dependencies, and if you had dynamic loading, you would create a script tag and insert it into the page, and when that script tag was loaded, you would do something with that script loaded. Then came around tools like the old Steel and then Require.js that provided like a much better way that you could define your dependencies for a module. You guys all know what hopefully AMD looks like by now. So you would kind of load some config file perhaps, and then load Require.js, and then specify what is the initial module to load. So yeah, this is what a module would look like, and this is what your configuration would look like for AMD. And again, just stop me if you guys have questions or I'm going too fast. This stuff should hopefully be, everybody should understand this. And then for AMD can do dynamic loading, which is great. You just at any point would call require and do a dynamic module with load. And then today also there's CommonJS as well, where you have essentially a site that you point it to some JavaScript file, and that JavaScript file will use CommonJS to require modules, but that is like automatically built for you by Browserify. And if you have kind of special things like jQuery that would need a shim, right? So because jQuery depends on a window object and things like that, if you needed to make sure that that dollar it doesn't deformally declare an export, you would set up Browserify something like this in your package JSON. You would say, oh, Browserify. You would tell it what to build and how to include plugins and things like that. And that would build on the fly. So currently, there's some pluses and minuses between kind of the Browserify CommonJS methods and the Require.js methods. What it comes down to me is Require.js does progressive building quite well because it has a client-side, a full-featured client-side dependency management, script tool. And then the Browserify has a lot of advantages because you have NPM and you're always kind of running from a build, which is nice. That you never have to really worry about then. Okay, it works in development. Does my build work? Does it not work? But that also has a negative, is that like you can't look at in files individually in browsers that don't support source maps. And even I've found that source maps don't always work. And again, if anybody has other things to throw in on this debate, please throw them in. So what ES6 module looks like, module loaders, is you could say, hey, I want to load a module instead of a script tag, and that is, you point it at app.js, and that will load a module.
Hey, Justin, is that supposed to be a script tag? No, next slide.
No. Oh, the ending is supposed to be a module.
Is this is kind of undecided, isn't it? The module tag. I think it's still being worked on.
Still debated. So I will say a lot of the stuff is, well, not a lot, but there are some things that are kind of being debated. But what's pretty certain is if you wanted to load app.js, somehow once you start loading that module, you can import things from it with this syntax here. This is what ES6 Module Loader syntax looks like. Right? That's how I refer to it. It doesn't have a better, I think eventually it'll just be called Module Loader syntax, but right now it's ES6 Module Loader syntax. It's this import keyword, and you give it a module name, and you say what you want to import from that module. I'll talk about it a little bit later, I think, but modules can have multiple exports and a default export in ES6. And then ES6 supports not only static loading, so your script's dependencies are defined statically, it supports dynamic loading through the system import method, where you give it a module name and then it returns a deferred that will be given the module value or an error if something went wrong loading the module. Okay, so let's check out that syntax and API for ES6 a little bit better. But first before we can get into the syntax exactly, I need to kind of break down the technologies involved with ES6 module loaders. So on a high level, there's three things. I'll break them down. There's the ES6 module loader, and what that is it's an abstract constructor function that lets you define other loaders. It's actually like a class that defines something that you can then use to load. So each loader instance contains a module registry. So if you actually can have multiple loader instances, and then if you loaded every time you load jQuery, and for one of those instances, it would actually make an AJAX request and load jQuery. Right? But if the second time someone loaded jQuery on one of those instances, it would not reload jQuery. Hopefully that makes sense. It's like it's a little contained world. These can eventually will even have their own implementations of arrays. So if you wanted just to have array, like you wanted to add methods to the array, those would only exist within one loader. Really cool things like that.
So did you say they all have the same registry, or they all have their own registries?
Independent registries. Each instance of loader has an independent registry. The syntax, this is ES6 module loader syntax, that's that import X from Y. This is just a new syntax that is being added to JavaScript to support loading modules. And then finally, there's the system loader. This is an instance of loader. It's a special instance of loader that is going to be like the default loader. So that if this kind of code is found, it's implicitly behind the scenes doing a system import Y, essentially. Unless you've kind of set up and configured your own special loader. So this is basically, again, this is just the system loader. It's an instance of loader. It is the like default loader. It's that default module registry that everything goes through. The default system, so the default system loader doesn't do very much right now according to spec. It doesn't have a lot of the things like, you know, configuration options that you might be used to from either require.js from Steel, such as map or like shim, things like that. All it does is it has the paths config, and it can do normalization of relative module names. That's basically it. All it does is, and it can only load modules that look like this, that use the ES6 module loader syntax. That's all this default system does, by default. Now, loaders, so this is the three things in there on a high level. The loader, as I said, is kind of an abstract constructor that can be used to create your own custom loaders. And to create your own custom loader, you create a new instance of loader, and by convention it's capitalized here, even though this is not a function itself, which is kind of confusing. It's really like just a normal, it's like an object with methods on it. But to create a custom loader, you call new loader, and you can pass it these hooks. These hooks control the behavior of an import on my loader. So if you do myloader.import, jQuery will first be passed, the name jQuery will first be passed through the normalize hook. The normalize hook takes what is kind of a module reference name, so something passed into import, and converts that to the full module name. So that's kind of what the map config in CanJS, or in Steel and AMD currently does. Or it'll also take a relative, a ./jQuery or / helpers or something like that, and convert it to the full normalized module name. And then it takes that modularized normal name, and then it uses that to locate the module, like where it is on either the file system or in the web. What's the address? Then there's a fetch hook that, given the address, essentially gets the source code for that. There's a translate hook that, given source code, can translate it into, you know, whatever kind of final source it should look like. Maybe you want to convert CoffeeScript into JavaScript. You could do that in the translate hook. And then finally, there's an instantiate hook that, given the source, figures out the dependencies. It basically returns the dependencies and returns a function that should be run once the dependencies have all themselves been gone through all of this and instantiated themselves. And then this execute is called with each dependency's kind of module value. And this will return the actual module value. This is kind of the flow of a module name through the entire ES6 module loader system. So I give an example of all of these. If you wanted a loader, if you wanted a normalized hook, you wanted a custom loader that, if you just passed in import bb/view, it would always convert bb/ to backbone/ whatever view was. It would always normalize bb to backbone. You could do it like this.
Just, I don't know if you said, but I think it's probably key that all of these hooks return, they return a deferred, don't they?
Yes, all of these hooks can either return a deferred or like the value that I've kind of expressed here. So another example, so let's say jQuery. So jQuery isn't something that would, doesn't export a value by default. And in jQuery UI, modules do not, well, actually, I'm assuming it does export a value by default for right here, but this is an example of, let's say I wanted a hook that anytime someone loaded a module jQuery UI, it would add jQuery as a dependency. So here I can overwrite the instantiate hook to detect when jQuery UI is loaded, and then return an object that always says that jQuery is a dependency, and then an execute hook that is going to get the jQuery module and set that as window.jQuery, and then eval the module's source code, and then remove jQuery from the window. This is the kind of instantiate hook, what it does. So the syntax, which is the part that hopefully, unless you're developing Steel, that you guys will be using a lot of, kind of looks like this. So you can import different values from a module. So this would load add from essentially what math exports as add, and this would set a sum variable as what math exports as total. And then the math.
Wait, is that right, or is that the opposite? It's math.sum becomes total, right?
Math exports sum, and I'm aliasing it total as total. Good catch. And then you export modules. That's how you kind of import them, and you can export modules like this. I could create an add function and just export add as add. It would do that. You can actually write as in here, even though I'm not showing it. I will in the next slide. And then you can export kind of directly, like named either variables or functions like this. I'm going to export sum, which is a function like this. So the full list of syntax looks like this. This just imports jQuery and whatever side effects jQuery has. That if it sets like global exports and things like that, that will just import jQuery. If jQuery does actually like explicitly export a default value, this will import its default value. This will import its dollar exported value. And there's a difference between something that's the default export and the dollar export, which I'll show in a second. And then you can do aliases as well. So I want to show the default, what I mean. So there's a special default export, which is essentially for this kind of syntax. But if you wanted, so jQuery might actually export dollar, and it might export a default, which are the same thing. So both of these syntaxes work. So yeah, you can export variables like this, and there's a default export as well that'll override like any variables, and that becomes, again, what's imported with this syntax. And then you can also export explicit variables by passing it in the variable like this, and you can alias it as something else. And you can explicitly export something from another import. This is kind of like doing an implicit import and export at the same time. If you wanted to like alias something, repackage it, and this would actually export everything from another imported library. This is not standard yet, this last one, but the rest of these are pretty well baked at this point.
Hey, Justin.
Mm-hmm.
Is there a way to like inspect all the exports from a module without like looking at the source code?
What do you mean to
like,
just
like how do you know? I mean, so you said there's a default export. Like when you say import jQuery, it just gets the default. But what if there are multiple exports that you're not aware of? How do you?
Yeah, that's a good question. I've never tried that, but let me see if you can do something like that. So I think there's a system.get. I don't think I'm actually exporting anything, but yeah, you can do a system.get in your module name if it's already been loaded essentially into the page, and this will show you what it exports. So there's a default export with just this empty object, and it's also exporting a use default property of true.
Okay. And then you might have already said this, but where does the module name get defined?
The module name is defined just like in Steel. It's really defined by like where you are in the file system a lot of times. Do you know what I mean? Just like in Steel, you never actually explicitly define the module name.
Can you show an example? Like go back to your code.
Like just think about Steel. Like can construct is like nowhere in this code does it actually say this is can construct, the module name.
So you just have to know the module, but actually I'm confused. So, but this is different because this module has a name.
What do you mean it has a name?
In Steel, we're grabbing the file by the path.
Yeah, but you can also alias the path in as well. It's not always the path. Like from
So
the
go back to your example. Like, where would crypto be located in that example?
Crypto would probably, by default, crypto would be located in base URL / crypto.js.
Okay, so this could include a path here, the slashes.
Yes.
The slashes. What do you mean the slashes?
It could be he's saying it could be, you could do can construct, can / construct like that to import.
Yes. Yeah, you can put slashes in here. Yeah, absolutely.
Okay.
And you do.
What about the like the inline modules? Is that still around?
The what modules?
There used to be a syntax where you say like module foo and then braces and you could have like an inline module.
Yeah, I don't think that's. I don't know. That I actually don't know. I've not used that, and I haven't seen it in Tracer to deal with that. That might be something to look into, but. So basically, I mean, it works just the same way as AMD or CommonJS. Like you never are explicitly defining your module name in JavaScript code. You know, you might use a path config and things like that to basically logically locate, given a module name, where it is on the file system or in the web. So I kind of talked about the syntax. So the system loader and all loaders have an import method, and again, you pass it the module name that you want, and that gives you a deferred that resolves with the module. Pretty basic. So the system loader provides that system. There's the system import method. There's also a base URL, and that specifies the default path to look for all module names. So this is kind of like Steel's root, or old Steel's root. So if I were to do system import module, that would look for module.js in JSLib module.js. So again, make sure you guys, besides Brian and Matt, are asking questions if you have them, just because we're going to start turning the corner pretty soon here, and I'll start pressuring you guys all into using this in your projects once CanJS fully works with it, which will hopefully be at the end of this week. So make sure you're asking questions. So system supports the base URL by default, and it also supports the paths configuration by default. And the paths configuration looks like this. If I wanted to say that, hey, any Lodash module, go look for that in util Lodash, and then we'll kind of replace whatever's kind of wild carded here and put that in here for the final path. So if I were to import system import Lodash map, that would include the base URL always, unless this had an HTTP or a slash or something that kind of escape it out of looking for things in the base URL. But it would look for JSLib and then use this path, util Lodash map.js. Okay, so yes, the dream, as I said, is to get Bitovi off of not having to maintain nearly as much dependency management code, while still kind of supporting what was special about Steel, which was really the build thing, and to be able to support like ES6 modules, CommonJS, AMD, basically everything out of the box. So I'm going to talk about, okay, so yeah, I just basically it supports, modules from every kind of AMD, CommonJS, everything. Let's kind of skip over that. It does support right now if you're going to be using ES6 modules, which are will currently work in IE 9 and above. It does support everything Tracer supports, which is cool. I don't know how many of you guys have projects that only support IE 9 and above, but if you do, it's awesome because you can use arrow syntax and shit like that, which is great. So I'll talk later about how the multi-build works. Actually, I kind of want to talk about how Steel works. So StealJS is split up, StealJS is really 3 projects, or is it really comprised of 6 projects? I take that back. Tracer, which is an ES6, a JavaScript. When I say ES6, for those who don't know, I mean ECMAScript 6, which is ECMAScript is JavaScript, another name for JavaScript basically, and it is a ECMAScript 6 compiler that outputs to ES5, and we use that, and SystemJS and ES6 Module Loader use that to, actually ES6 Module Loader uses that to load modules that it detects as ES6 modules and transpile them into ES4 so that we can kind of like fake loading ES6 modules. The ES6 Module Loader project provides that loader constructor function that we talked about and the default system loader as a polyfill, which is cool. The SystemJS project extends this default system loader object with all the configuration options you guys are mostly used to for something like require.js. It includes a map, a shim config, just a whole bunch of other configs, which I'll talk about in a second. A lot of the stuff happens in there. Then StealJS is our module loader that builds on SystemJS and ES6 Module Loader and Tracer, that all it really adds to SystemJS is the same kind of, it can load less and it can load CSS plugins by default, and it adds that same like load a configuration file initially, then load dev tools, then load your main module. So it kind of does workflow stuff and knows how to switch between environments. And then for Steel Tools, there's a transpile project that Bitobi kind of owns that allows you to transpile from one format to any other format, from like CommonJS to AMD, from AMD to CommonJS, from ES6 to AMD, and so forth. And that uses a lot of Esprima underneath. And then finally, there's Steel Tools that does essentially system. What I've really done lately is now it only uses the system configuration options and to build from a normal system loader. So it's actually shouldn't depend. Steel Tools, in the long run, it might a little bit right now. I haven't tested it not using Steel, but none of its code really should talk to Steel directly. It really should be an independent ES6 module loader, so that in the future we might even be able to drop Steel here, or just have that a few plugins that we like, and then just use SystemJS on top of ES6 module loader and have Steel Tools build it. Any questions about that? Just the over. I'm going to go into them in more detail. All right. So Tracer compiles, like I said, it just kind of compiles ES6 code into something. So it would kind of take this import $ from jQuery and actually output this JavaScript code like this. Basically, make it so it tries to use CommonJS to require jQuery and get the default value from it. Another example is you can also use tracer to kind of parse into a source tree, and which is very handy so that you can pull out the imports and things like that. Kind of give you a source tree.
Hey Justin.
Yeah.
Why is it that tracer needs a runtime?
Tracer needs a runtime because tracer's output now is written to include that runtime, which sucks. Because I think it basically makes the source code smaller. The generated output over a big project will actually be smaller with the runtime, because you can imagine if every time it had to write out what assert object was doing, asserting that this was an object, if it had to write out that essentially what's that code, that function inside that code is doing around this, it would actually be a bigger overall in a big project. Does that make sense?
Yeah.
Yeah. So I think that's why.
But it's not like evaling or anything like that. It's not evaling ES6 code when it does that.
No, no. So yeah, we also use the source tree for things. It's kind of like a Sprema tracer a little bit too. Can be used like that. So the ES6 Module Loader, we already talked about what that does. That polyfill essentially provides this loader constructor up to the spec, and also provides the system loader which again has the base URL config and the paths config and this import method, and not very much else outside of that. Then there's SystemJS, which I did not change this link down here. This has a bunch of extensions that weave themselves into system, and I actually might show you guys what this looks like, just because it's so important to, like, if you're going to ever develop, you know, your own behaviors or improve Steel or SystemJS. It provides all those plugins. So it has an extension, or extensions, what it calls them. It has an extension for AMD, for CommonJS, an extension so that globals like jQuery or underscore that don't actually like export anything with any syntax, so that they can be used. It has the shim, which it calls meta config, which is so you can shim globals. It has bundling, versions. It has the map config. It's basically all the configs are almost all there. Steel adds a few, but most of the really hard, tricky ones are in SystemJS. It even now, even though I haven't started making use of it, it does things so that it can, instead of making AJAX requests to fetch the source code, it can actually inject script tags and kind of bypass. So that way, right now, Steel does not work cross-domain, but SystemJS does. So Steel should technically. I've just not made it so that I've not experimented and tried to figure out how to make that work. But SystemJS does support that.
Your link at the bottom's incorrect.
Yeah, I pointed that out earlier. Yeah. So yeah, SystemJS has all the formats. AMD, CommonJS Global. I guess I go through all these. It has the meta or the map config, which hopefully you guys are used to. So if I want to just import underscore, but have that really look for Lodash, you can do that this way. The meta config allows you to say, if I have jQuery UI, I want, which doesn't, import or require its dependencies in any way. I can explicitly define its dependencies and say that it's in the global format or whatever. I can specify bundles, which is great. This was basically already made so that we can write production files and say that, hey, this main bundle file module contains the main module, jQuery, and CAN modules, which is really cool. So that if somebody were to import jQuery, it would actually look here.
Did you insert some logic that makes this work with the Steel pathing, where if there's no JS in the end, it adds another like core. You know, UI core means UI core core.js, or is it?
What?
Does this work with the Steel pathing, or does it use just normal pathing? So if the path
No, so these do not anymore work with the Steel pathing. So if you had main, you'll need main/main.
Okay.
You know what I mean? It doesn't do that. Now, old application Steel, if you're using Steel syntax, that still works the same way it used to. And if you're still setting like I'll kind of show, if you're still doing the kind of script tag that says source equals StealJS ?main, that will load main/main.js.
Okay.
Your configurations are going to probably have to change, but none of your source files and probably not your HTML files either. Those things should still all work. But all configuration now is like, you know, true module IDs, not like kind of adding the slash anymore. But you can actually add, you can write main/, I take that back. You can write now main/, and that will add main/main.js, which is actually, I forgot about that. Anyways, so SystemJS also allows plugins. It does provide them, but the ones that it provides don't work well in a production environment, so we had to rewrite our own for less in CSS. But it does provide the infrastructure to support plugins. So it allows you to kind of write foo.css, bang CSS. And to create a plugin, like a CSS plugin, I could essentially, your CSS module, your CSS plugin would have to export an instantiate method that would be given kind of this load object, which I'll kind of talk about a little bit later. But essentially, you would add your create a style element and add that to the page with the load source, with the source that was loaded at foo.css. I did that. So and it also, so right now the biggest change, actually, the one place your modules, your projects will have to change is you can no longer just write foo.css. You have to include a bang after it at least. So you have to write your modules like that to let them know that to load a plugin. So what Steel does, it's mainly there to support the same kind of conventional stuff that we were doing before. Allows you to specify a main in your script tag like this. And by default, this will do the same stuff Steel has always been doing. It'll load Steel. It'll assume base URL is in this root folder because it'll say, oh, Steel is inside of a Bower component. So we'll just, by default, assume base URL is there. It'll make sure it knows where to find CSS and less inside the Steel folder, and it will import root Steel config, just like it used to, and then import root main.js. So we also support the EX, so that you don't have to write this, like to say that stash I want to load as a plugin, like this. We support an extensions that says, okay, well, anything that ends with stash, bang, you can just write out can stash system. And then you can just write it. You can't write it like that. I was hoping you would be able to, but you can't. You can write it like this then, with the bang. Production, that does this exact same thing. I'm actually going to skip through a few things real quick, just because I want to get into like how it works. Because all of this stuff you should be familiar with if you use Steel, so you know about the less plugins and that kind of thing. And then Steel's build, that just does its multi-build, which hopefully everybody's familiar with. Stop me if you're not. Quick, any questions? Because then I'm going to go into like the code a little bit. Questions, comments, concerns. What do people think about? What do you guys all think about this project, first of all? That's what I care about. I know I went through a lot fast, but you guys could have slowed me down.
It's a lot of projects.
There are a lot of projects.
Yeah.
So far, I've only used, I guess, Steel within an existing project on MindJet stuff. So are a lot of these steps on how to set this up from scratch if you're starting from nowhere listed either in a guide somewhere or explained just in general?
By setting up from scratch, you mean
Like
what?
starting, if you start on a brand new project, no existing code anywhere, how do you get from an empty file to this setup so that everything's being done in the right way?
Yeah, so there's like a quick start guide, which I think you even made comments on, that does walk through like the basics of how to set up a new project for it. Does that make sense? So I'll show up. Let me maybe instead of going into the code, let me show you like an example project that I wrote, and you guys can see how that looks. But let me answer the question: is Steel's root always 2 directories up, or is it Bower components a special part of the string? No. So the rules are. Let me show you the rules. It's not letting me select my browser window. So let me show you the rules here and kind of give you. So the website is basically, if you want the API for the module loader Steel, all that is in here. Oh God, I know why that's happening. Okay. There's I just encountered, Brian, I just realized the capitalization issue, you know?
Oh, yeah.
So I got to like delete everything and re-add it, which sucks. Anyways, so hopefully these links all work. Okay, good. So there's your base URL. Base URL is really determined by kind of the rules in Steel path. So when you set Steel, when Steel is loaded, that sets an internal property called Steel path, which kind of has side effects, which are explained here. So just by when loading Steel, it tries to get at those default values. Base URL. So if it ends with Bower components Steel, like if Steel is in something, if StealJS is in a folder called Steel, which is inside a folder called Bower components, it will look basically next. Your root will be kind of the parent of Bower components. If the path does not have Bower components and it's just you're inside something, Steel is inside Steel/StealJS, then it's just going to be a sibling of that top Steel folder. Just that was kind of what the behavior was for old Steel. And then if not, if it doesn't match these conventions, root is just going to be like the current page, I think. It's just going to be, or no, it's going to be the, it's just going to be wherever Steel is found, actually.
I thought it's where Steel config is.
That's because Steel config sets these values. So
Oh.
no, so sorry, Steel config can, so that's if that's Steel path, but
Right,
Steel
right.
config can overwrite that. So if you set the path to config, you can actually, by setting the path to where your config is, it will assume that the config is in your base URL as well. So it'll set base URL to the folder of Steel config. And this stuff is actually documented now. It really is. It's all like pretty decently documented. all the rules. I mean, it's tersely documented right now because I was like more just concerned about getting all of the rules in, but it is there. So let me show you a little basic app that I created that works. So here I wanted to create a progressively loaded app that used like all different syntaxes and make it work. So here I can essentially log in. I can go to these different pages from the home page. I can go to jQuery UI and it loads a jQuery UI widget. I go to Bootstrap and I can go back to the home page, and it works with the back and forward button. Right? And the cool thing is if I log out, here let me be on Bootstrap, and I log out, it doesn't like go to a log out page. It kind of keeps turns to it when the person logs in. So let's see how I got this to work. So, okay, I have my main page. Actually, I'm loading production now. Let me move it into development. Okay, so I have my main page, and it's loading StealJS in Bower components. I've installed Steel with Bower, and I've installed Steel tools with NPM. So Steel tools and Grunt. And then in my index.html, because I'm loading Bower components, Steel, that means my root folder or my base URL is essentially this Steel can example folder. So main is going to load up here. It's going to initially load main.js. And main.js is going to load just what's needed to do the routing, which is kind of like can.js and jQuery and kind of the site as a whole. It's saying to like the links on top. Basically just some, okay. Just like this Steel can.js example as part of the template, and things like that. And for the most part, what it's going to do is listen to, on the app state, this show page attribute changing, and then import a component that matches that attribute. So it's going to load, like if I were to click, if the, essentially the, why do I keep clicking on that? So if Bootstrap is up here, it's essentially going to load components bootstrap slash, and we do support the end trailing slash, so that will add, make it actual, the module load will be components bootstrap slash bootstrap. And then it will insert a little template for that component, and then that component will kind of become alive. I've got all my components here, so I can show you what the Bootstrap one looks like. This one is using AMD, and all it's really doing is loading Bootstrap, and has a template that like renders Bootstrap essentially. Let me show I think my login one is an actual ES6. So I have them all in different, this one is with CommonJS, and I think this one is with Steel. No, this one's with ES6 as well. So they're all different formats, and they got basically create a component that has some behavior. Let me show you the config file looks like. Config file looks, just call system config. Now you still can call Steel config, but you should probably start aliasing to system config. I do have a migration guide that I've started putting a lot of these things in, which is migrating here. Basically, all I do is I just map the location of jQuery, because I've loaded Steel and jQuery in Bower. and Bootstrap, basically everything in Bower. So I'm just mapping all of those paths to Bower. And I've set up my extensions to make sure that if I'm trying to load EJS or Mustache or Stash, it's going to actually use these things as plugins to control that plugin, and the bundles that I want to like the multi-build to operate on.
Hey Justin,
Mm-hmm.
can you show the production app again?
Production app.
You show the browser, sorry. Can you show what
In production or in development do you want me to show you?
In production.
Okay, let me put it back in production.
I just want to see what other files is loading. Is it just Steel or is it any of those other dependencies as well?
What do you mean?
Like is it loading? So tracer happens at build time, right?
Yeah,
so
it doesn't load tracer in production.
Was it just loading Steel?
It loads Steel, and you can actually now include Steel in your bundle, which wasn't possible before. I didn't do that. There is a
Bundle Steel, I think.
bundle Steel that you can set to true, and that will actually include Steel in your main bundle. But then so that would actually reduce the number of requests by 1. But here you can see the network traffic here. So here. So it's loading what's shared by Bootstrap jQuery and jQuery UI and Bootstrap CSS and like just the Bootstrap module, because there's like overlapping dependencies between jQuery UI and Bootstrap, which is probably just jQuery in here.
Mm-hmm. Does Steel now include like the system loader, shim, and all that stuff?
Yeah, it includes that polyfill as well. So eventually Steel will not need to include that because it'll be in browsers, and we'll probably have like a different version of Steel. We'll build a version of Steel that doesn't include those, but right now StealJS includes it because no browser includes the module loader.
Does it make it a lot bigger than it used to be? It looked like it was, go back, I think it was 1.
Yeah, it's big. Well, this is the development version. Yeah, but it is bigger. It's like 12K now.
Click close on that tab. I thought it said 153 kilobytes.
Well, this is unminified and not gzipped.
Oh, okay.
So it's minified and gzipped. It's like 12, something like that.
Okay.
It is bigger. However, our build we're very close. So we actually export everything into AMD. Like no matter what the type given, we export it into AMD. So it should be possible, fairly easy, to make it so you can use require.js or something like that in production. And if you have to use require.js for productions that do progressive loading, but you could even use like an almond for something that's like a single output basically, which would be cool.
Can you explain what you mean by that? You can use almond to do what do you mean single output?
So like a page that everything is in one production file.
Why wouldn't you just use pluginify for that?
And you could also just use pluginify for that too. I don't know if maybe there's limitations for pluginify. I don't know. You probably could just use pluginify.
Is pluginify part of the new Steel tools also?
Yeah. Its API is a little bit different. There's basically, you call this pluginifier, and that returns a function that you can call pluginify. But there's command line tools that aren't as like this. If you're doing it programmatically via JavaScript, but it's stupidly fast now. Yeah. So the one thing I did want to go through, it's worth a look at, because I do want you guys being able to contribute and make fixes and things like that to this. I did make a nice kind of contributing guide that kind of walks through Steel's code on a high level, and then explains like explains how Steel Tools works on a high level and kind of where things go. And I just kind of wanted to walk through this just so that everybody is kind of forced to understand it, so that if you do find problems, you're not as wary about doing it. StealJS itself now is really simple. This walks through kind of its code on a high level. Essentially, its code on a high level, it includes the ES6 Module loader. Includes the ES6 Module loader project and SystemJS. Those are its kind of first two things. And then all Steel is essentially, there's the Steel function. Actually, I'll just go through the actual code. I'll show that. You guys have me.
So is Steel a module loader itself, or is it everything goes on system, right? We're not.
Everything goes on system now. You actually never really talk to a Steel function unless you're actually calling Steel to get your dependencies. So really, Steel, almost all of its code that matters is in two places. It's in this config file that adds the configuration values that Steel doesn't provide, or that SystemJS doesn't provide by default. So things like some backwards compatible stuff, like root, start ID for old projects. Those are all like handled here. If you want to set env, when env gets set, when base URL gets set, like when anything basically, when that Steel path and all the defaults that happen, because we know where StealJS is, those all happen here. Almost all of there's an instantiated hook that was so that you can prevent production CSS from loading. All of that kind of stuff, vast majority of it is all in this one file. The only other place where there's a lot of stuff is startup, and this gets called when Steel is first started. This is what's going to get Steel, find the Steel script tag, pull out whatever options are from it, and call system config with those options. Instantiate anything that needs to be instantiated. Actually, this should be removed, which I'm going to remove because that doesn't need to happen there anymore. Good code review. And then just do the right thing depending on if you're in production or development, right? Import the config module, then import the dev module, and then load your main module. That's where everything StealJS happens. What's much more important now is to actually understand the system project, SystemJS. And I do want to show just like a little dummy example of just can explain how system works and how it's organized. So system is broken up into all these extensions. For instance, let's take a look at the map extension. That allows that map property to be set. It provides a function that is going to be called with the system, with a loader, and it's going to set a map property on it, and then all it's going to do is overwrite that loader's normalize hook. It's going to replace it with another normalize hook that's essentially going to look through those map properties and then call the old normalize function. Right? This is the behavior for all of these hooks, is essentially get the old hook that you want, replace it with a new one that does some behavior based upon some configuration object. And these are just helper functions to like crawl through that map object and see if like what's it called? The module name matches something in the map. That's all it does. So, let's see, I thought there was some other. Any other questions? Oh, Steel Tools. I don't know what that's for. But Steel Tools, I just wanted to say how that's organized real quick. On a high level, Steel Tools, all it does is it loads up a module so that it's never actually instantiating or executing any of the code in all of the modules. It's just picking out all the dependencies. It builds a graph that looks like this. The better example is it looks like this, with the name of each module a load object that includes the source of that module and all of its dependencies. So here can utils dependencies on jQuery, and what bundles it's in. And all it does is it just transforms this object here into bundles that look like this, where the bundles have kind of these objects on them, node objects, and the size of the bundle, and then it writes those things out. That's all StealTools really does, and it's organized by it's really a functional approach. There's a bunch of functions that operate on bundles or graphs or nodes or on the configuration that someone passes. That's how StealTools is organized, all in this lib folder. So everything that operates on a graph, like, hey, if you wanted to get an item from the graph, or if you wanted to go through every dependency in a graph, if you wanted to make a graph given some configuration options, or minify every option in a graph, that's kind of how this whole thing works. Is everything in here either creates a graph or expects a graph as an argument and does some transformation on it. And that's how it all works. And there's basically this build, the multi-build, that it just walks through all of those kind of transformations. Gets a graph, then removes the config from it, and removes the dev from it, and then orders it and transpiles it into AMD, minifies it, and then essentially writes all the bundles out. Gets all the bundles, pulls out bundles from it and writes them out. That's it. So that is, were there questions, concerns? What's most, I know this was kind of an ad hoc presentation. I thought I was going to have more time to prepare for it. What mostly I want is not about the internals or how to use it. I just want to know and address if people, want to be spending time working on this, think it's a good idea, that kind of thing. I think there was a question. But
there's some Q&A questions.
Okay, so yeah, I already answered that one. Why is Bootstrap CSS mapped to the URL that ends with? Okay, that is just a stupidity of ES6 Module Loader. So, I don't even totally get it. That's just a total weird, crazy issue. But I did document it where you can.
Could you explain what the question is?
Yeah, let me. So, Mikhail asked why. Am I sharing my screen still?
Yeah.
Okay, so in can example here, if you look at the Steel config, why does it look like this? CSS like that. And the explanation for that is because the paths implementation of ES6 Module Loader is really stupid. So I did document why this is and why it's weird. Yeah, so I gave another explanation on this one. There's places on why it's weird, why CSS and other extensions have strange rules. I asked Guy Bedford, who kind of maintains it, for an explanation. And essentially, there's some weird thing where it always removes, anytime a path happens, it always removes the last 3 characters because it thinks it's always removing .js. But in that case, it's actually removing CSS. So there's this weird, there's just this weirdness of mapping extensions. They're actually thinking about, there's some patches that are going to change this in future versions, I think. There's been a lot of talk about how to fix this problem. So it should go away. But for now, that's how you have to specify paths, which is stupid. Now, I should say that I'm thinking about even writing a Steel, like our own version of paths that matches exactly Steel's old version, because Steel's old version didn't have this problem and was a little bit nicer. The greatest thing, the reason, and I'm trying to make this pitch, ES6 Module Loader, by and large, even though some of the outlying things are kind of weird, like why there's that paths problem are weird, the internal core and the way that you can add your own hooks and add your own behaviors is amazing. And it makes it so that you can really get whatever behavior you want out of the system loaders. And because that, we're never going to be like pigeonholed. As long as this gets adopted, we're never going to be pigeonholed in any one kind of like functionality. And this is also, so to bring up, like, what's the one that Josh Marchand and what are Josh Marchand and they're using at Apple? The other kind of competitor to this?
Webpack, is that it?
Yeah, Webpack or something. The reason why I'm a much bigger fan of this now than Webpack is because there's a standard spec for doing things like adding extensions, adding plugins, adding, you know, like CSS plugins and things like that. Where our Steel tools right now, if someone else writes an extension, a module extension or whatever, Steel tools will just work against it. There's nothing we have to do to make it work with someone else's behavior that they want to add to a module loader. And that's really powerful, and I think it sets us up for like 5 years from now that this stuff is all extremely relevant that we're kind of doing today. Even though I think the spec probably, this is going to land in browsers for probably another 6 months. I think once it does land, if we kind of ride this like little bit of weirdness where like, you know, like that CSS extension thing wasn't working, we'll be in a really good place to just work with everything and not have to like pick and choose. You know, we're not really picking a winner other than I guess we're picking a winner that the ES6 Module Loader gets in browsers. But once that, because it's such a flexible system, it should be able to work with everything, and that's why I'm a big fan of it. Anyways, I thought Josh had a question, which was like, how backwards compatible is this?
Yeah, I had 2 questions specifically. The first one was, on a scale of 1 to 10, how backwards compatible is this with legacy Steel? And 2, I'm not sure if you went over or not and I missed it, but how do I do production builds on new Steel in comparison to how I would do them in previous Steel with handling, say, Steel production?
Yeah, so to answer your first question, is it backwards compatible? Like, only the most simple application would require no changes. Anything that's loading CSS or a template is going to require at least putting a bang after the module name. Now, we could actually make that go away, but in ES6, you're always going to have to put a bang because you can't, there's a weird contradiction with bangs that like you can't remove them, which Manuel and I discovered. So at least if you're loading CSS or like an EJS template, you're going to have to put a bang after all of those. But actually, that's probably all you're going to have to do, that and maybe change your config around. If you've got a lot of paths stuff, you're going to have to change it from, instead of just kind of like our old paths, which was just end with a slash, you're going to have to make it end with a slash and include a star, and then you're going to have to change around the paths config. But other than that, it's actually pretty darn backwards compatible. It's not something that a good regular expression to find all your .css's and just quickly change around the config are not going to find in like half a day. You should be able to convert almost anything.
Okay.
I'll temper that by saying that once CanJS is fully working with the new version. So we have to, with the new version of CanJS, you do need a new version of CanJS because the templates and things like that need to work with the plugin system that ES6 Module Loader provides, and not Steel's old plugin system.
Okay, so asterisk, 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 almost there, but not quite yet. Got it.
I mean, I would say
what version of CAN is going to be the one that supports it? Is that like the one that's coming out like immediately, or can we use new Steel with the old CAN with, like, I don't know, some massaging or something?
Not with if you're not using templates, if you're not loading templates.
Oh, well, definitely loading templates.
So then you have to. You could get away with it. You just have to do two things. You have to steal. So let me talk about the build, because this kind of answers your question about the build. So in this example, there's two ways to do a build. You can do it programmatically right now, where you can just require Steel tools and then call build with the location of your configuration file, and then the main module you want to build, right? And then you can provide a bunch of other options to configure it. Like if you don't want to minify it, you can put in minify false, that kind of thing. That's how you do the build. Pretty straightforward. It does output into, instead of production.js, it will output into a dist bundles folder that will, like, match, instead of production, it will be called main.js. It'll match whatever your module name is. That's one way. The other way is with Grunt. You can specify those same things in Grunt. Steel build, it's a multi-option Grunt or whatever, so this is like, okay, this is the main Steel build, and then we want to pass the options, system configuration options of config and main. It's kind of object-y, a lot of objects nested here, but it's essentially the same stuff you pass to the programmatic version.
I guess my third question, which is to supplement my second one, how I currently do the production stuff right now is I get steel.js, and then I'll check steel.config environment to see if it's production or not, in order to choose whether or not I'm going to either steal the production file, otherwise, steal my normal one as normal. Does that still exist in New Steel, or is there a better way of going about it?
So, well, there's still the environment. Like, I guess, I'm not sure exactly what you mean, because normally, like, you just lay this environment production, and then that takes care of checking the environment for you. Do you know what I mean?
Okay. So I suppose to say, and people who are watching this later might not necessarily get, well, what I typically do is something like steel.config, and...
Are you talking about beforehand?
That is
yeah,
what I would...
to do conditional stuff, right?
Right.
Yeah, so you can, steel config still exists, and steel config end will still return either production or development.
Okay, I just want to make sure that was the case.
In the future, what you should be using is system.end to make it more future-proof. Yeah, but these kind of backwards compatible things I tried to keep in as much as possible. Okay, if you wanted to use old, so the biggest thing, if you want to use old steel, is you really need to, it all really comes down to, you'd have to copy a few files over from this branch that we're working on called System Steel DOMless, which I think is this branch, but I'm not, yeah, okay. So the biggest thing is, you'll see in this steel config, I have a build config option that says, hey, when you're building can util, I want that to be can util DOMless. Because can util, by default, is mapped to jQuery, and jQuery does not run in Node. So you need to map.
Justin, you're not sharing your screen if you're trying to.
Okay. So what I was saying is, in this Steel config for Steel can example, there's a build config option, which is documented, that has overrides for essentially the build loader. Essentially, there's a copy of the system loader that we make to load plugins with. Right? So if we need to build an EJS template, we actually need to run some code in Node. And this has overrides for that special loader that is actually going to run in Node. And we can't run jQuery in Node because jQuery will break in Node. So we need a version of CanUtil that essentially, like CanView Mustache system, CanView Mustache system is like a plugin. If you're loading, let's say if you're loading Stash, if you need to load a template, I'm kind of being backwards here, but stay with me for 1 second. If you load a template, require a template, if you wanted to do something like Stash, and you wanted it to work right now, you need to define a Stash plugin. Now, there's already a Stash plugin in this branch, Steel System Domless, that you can use. And you could just copy this wherever you want and then just change your config to point there instead. So you could just copy CanView, and maybe I'll make this available so people can do it. CanView Stash System. You just need this file. But this file, it is essentially going to read a it's going to essentially translate a Stash file into something that returns a Stash renderer function. But that, of course, depends on Stash, and Stash itself depends on CanUtil, and CanUtil depends on, by default, jQuery. But we don't want it to actually, for this code to run, we don't want it to be calling out to jQuery. We want it to be calling out to something that can actually run in Node. That's why we have, in our Steel config, something that overwrites CanUtil to point to CanUtil Domless. And this branch contains a version of CanUtil, just like all the Zepto and other ones that Curtis wrote, that has a Domless, and you would have to basically copy this file. So all you really have to do to get it working right now in an older version of CanJS is copy these versions of plugins for whatever template you're using, and then copy this Domless.js, and then just make sure your config points to those, the exts point to those files, and the config points to that Domless JavaScript file, and then it should work and build fine.
Domless has a few dependencies as well. There's like a make array.
Oh, does it?
There's a couple. Yeah.
That sucks. Maybe there's more than that. That sucks. We should. I wonder if we should remove those just because, or we can make or you could pluginify Domless, right? We could make a pluginified version of Domless and then let people use that for old versions of Steel. We could do that. We will do that. I'll do that. So
there's also like those like weird partial stuff going on. There's like a few edge cases.
Okay. Yeah, there are, like, so if you're using partials, but you can work around those, right? Yeah, you can just register your own templates and work around them. So it's not too bad. And my plan now is to get, now that I've kind of got this working, I'm going to publish this version of Steel, and then I'm going to start working on CanJS, get a new release of CanJS out with bug fixes, and then I'm going to get a minor branch that includes all of this that works, and that you guys can use in your projects. So, and it will be part of Steel CanJS 2.2, I guess. So, cool. That is it. Any questions, comments, concerns? No.
Nope.
David?
I don't know. I said it to Alexis. I personally just think it needs to work.
What?
It needs to work in the projects we want to use it in. And it's still, we still run into issues with it, right? So that's the highest priority for us right now.
Yeah, what is the current issue with, is it, oh, it's just, all it is it works, it's just it needs to be merged with the latest master, right? That's the problem. It's more CanJS, getting CanJS working on it. It's not a problem with Steel, it's a problem with CanJS working on it, right?
I don't know. I think the fact that CanJS needs to be changed is a problem with Steel.
What?
Why does it need to be changed?
It doesn't. It's just there's been it doesn't need to change. It's just the plugins need to change, and there needs to be the DOM-less thing that I just pointed out.
Yeah, I know.
But I think it's just because there's been SystemSteel DOM-less hasn't been maintained and kept up to date. And then the other thing is we need Pluginify to work correctly and the tests to pass. That's the big thing. It's not a problem with Steel, more as it's a problem with. Well, I guess there's maybe some bug in Pluginify that you found, Matthew. But
yeah, there's a couple. I'm gonna fix them.
But those things will, problems will always exist in, even if we take off-the-shelf technology. There's problems in every open source project. I've found like probably 15 bugs in jQuery over the last 5 years. What I more care about is, is this something that, you guys want to work on, you think is important? If not, that's fine. You can absolutely, speak now and speak later and never hold your peace. But it's good to have these discussions. Because I really think like Steel is right now in a really good place. I did talk a little about a roadmap. I think it's in a good place to kind of smooth over a lot of, well, it's a good place to improve performance on a lot of our apps because of the multi-build. And it's in a good place to help a lot of workflow issues. And there's a lot of cool things that can be done because we have the system loader, right? We can have lots of different plugins. We can start using Tracer now and start using ES6 syntax in a lot of our projects and kind of get ahead of that.
I think it's pretty compelling that we can use ES6 and it's like part of the build and it's not an extra step we have to add. It's pretty awesome.
Justin, one thing that I remember reading SystemJS was going to do, I'm not sure if they did it yet, is have like a config for a module would have its own config, like scope to that module. So like, for example, can could do its own config, so you wouldn't have to do can util jQuery. It would just do that automatically.
I don't know if that's on the individual module. I think it's more, it might be. I know there's definitely that on the individual loader objects, and I know that there's modules can kind of have their own version of window essentially, so they can have their own implementation of arrays and things like that, which is really, really awesome. Like that way you can add things to array. What do they call it? I forgot the name that they call it. Like there's some name for that. Intrinsics. You have your own intrinsics, which means you have your own version of array. So you could say, hey, give me underscore and add everything on underscore to array, or give me some module that like adds everything in underscore to arrays. And then I can have my own array that has all of those methods on it, but everywhere else it sees array, a clean version of array. So you can actually write to like objects now, whatever functions and methods you want to add to them, like native objects. You can actually add things, which is freaking cool. You can't, sorry, when I say now, I mean later. That's not part of the ES6 module loader polyfill, but that will be that is part of the specification. So I do have a roadmap. My big things I want to get to, and you guys please help me influence this, things that you want for your projects. Always be thinking about what can make our project faster, build better, you know, what kind of dependency management problems are we solving. My priorities are the multi-app build, which is different than the progressive build. Right now it's doing the progressive multi-build, but we need like the multi-app build, which basically means instead of a single page app that will load kind of pages progressively, a build that's designed for multiple pages to kind of figure out their overlapping dependencies and build those out into separate bundles. The next thing I want is watch builds. So if you're, like, you can just set it up so anytime a file changes, it just spits out a new build. That should be.
You get that for free with Grunt.
Yeah, but you would have to redo the whole loading everything and transpiling everything. So I was actually want one that is super fast, where you, it's smart enough to say we keep that object, that graph object in memory, and it's smart enough to say that, oh, this file changed, which is this module did a dependency change. If a dependency didn't change, all you need to do is reminify that file and then just write out that one bundle, and you don't have to reminify anything else. And then if the dependencies did change, well, then you have to redo you probably need to redo the whole build. But that way, we can have extremely fast builds.
Wouldn't that make more sense to have it in general? Like you store it somewhere, the graph somewhere in a file, in like your home directory for that build, and whenever you run it
that
again.
graph includes every, I mean, you could, but it would be a, I mean, you could, it would just be it would be a big read. I was wanting to just do this kind of thing, keep it in memory, because if you had to reread that, it's going to include every single file and all the source of every single file. Which
if you can wrap it in a single file, it might be easier. Oh well.
Well, no, it would be in a single file. I'm just saying it's going to be a big file, and you're going to have to convert that to JSON. Where if you just kept that in memory, it would be much faster. You wouldn't have to output and reread that every time. But maybe that's a faster way of getting it to start. I just, you know, that implementation doesn't matter to me this much. I just care about the performance. I really want a high performance like watch build. So right now, all this, you can only use ES6 Module Loader in IE 9 and above, and Tracer in only IE 9 above, and all those syntax things. I want it. They're working on making it so that we'll be able to use the import syntax, ES6 syntax in all browsers, but you won't be able to use the tracer, like you won't be able to use array comprehensions if you need to support IE8. But you do get the syntax, because I eventually want to convert CanJS over to using ES6 syntax, and we can only do that once Tracer can output something that doesn't rely on getter setters when it does its transpiling. The next thing I want to add are development packages. I really want to be able to say, like, well, I'm never editing anything inside of Bower components. So build a bundle with source maps, essentially, so that you only have to load one file. You're never having to load everything in CanJS independently. You just load that one file. And to be able to easily specify that. So in development, you can load these kind of pre-packaged bundles, so you get faster load times in development. I think that would be cool. That's what my roadmap is. So today I should be able to get it out, a 0.3 version. And then I'll work on getting CanJS totally legit and ready to go, and then hopefully you guys can start using this in your projects starting next week. We can have a big official release. Cool. Anything else?
Awesome. So something like next week is what we're thinking?
Yeah, I'm thinking by next week I should be able to get, like, if you do want to use old versions of Can, or if you want to use the minor version, I should be ready for you.
I mean, I'm not necessarily opposed to having us upgrade to CanJS 2.2. I just want to make sure that everything kind of lines up properly. I don't know. I don't want to necessarily put, Shortell, for example, through having to do 2 back-to-back changes in a row, as opposed to just doing them both at the same time.
What do you mean by?
Like, I don't want to have them update to new Steel and then later on update to another version of CanJS that will be even more acclimated to the new Steel, is what I'm saying. So if they're both going to come out at the same time, it's definitely
No. So this would not be a 2.2 version. This would just be, like we had the minor branch for 2.1.
Yeah.
We never really we didn't release for a while, but we released, but it wasn't like the final version of 2.1.
Sure, yeah.
That's what this would be. This would be like 2.2 pre.
Oh, okay.
That would have everything you need and would be a download and have these, like, these the DOMless and the template plugins packaged with it. But I'll just make a standalone download that has the DOMless and the packaged plugins, so that you can use it even with old versions of CanJS.
Okay, cool. I don't know. I'm pretty excited about this. It's kind of a more shallow reason, but I'm really looking forward to being able to make a build and then not have enough time to go get a cup of coffee before it's done.
Yeah, it's stupidly fast. Oh, and by the way, I rewrote document.js to run on Node, and I made it so that there's the option where it just outputs the files, and it's like instantaneous producing Steel's documentation. It's so insanely fast. It's really cool, and that's kind of what I'll probably work on next is document.js, and then I will finally get FuncUnit to fix those things that Alexis and I have talked about forever. And then maybe Testy, hopefully David will have time, or I can help David with it. And then we will have a full stack on Node again, or not again, on Node finally. Everything with its own website, everything beautiful. It'll be a very good day.
I like a good day.
Yeah.
Good days make me happy.
So all right, that's all I got. Thanks everybody for coming and watching. I'll probably make a more eloquent presentation or presentations for all of this. What I really care about is just getting you guys to use it and getting you to feel comfortable with the code. Or some people. Not everybody needs to, I guess, know Steel, but having a few people who are interested in it, who want to work on it, who like the ideas behind dependency management and that kind of project. Getting a few people like that on board with it would be great. So if anybody's really interested, really wants to learn it, let me know, and I'll give you like a guided tour through its source and how it works. Cool. All right, thanks guys.
Cool, thanks.
All right, bye.
Thanks much.
Bye.
Yeah.